Hello students, in previous video we have seen the exercise questions of lesson electricity from question number 1 to 7 we have solved. Today we will solve the question number 8. The question number 8 is here. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. So this is the question. So here we have a 12-volt battery. Okay. So we have here a 12-volt battery which is connected across an unknown resistor. So this battery is connected to a unknown resistor, right? So when it is connected through to the battery, there is a current is flowing in the circuit which is 2.5 milliampere, right? Now we have to find out the value of resistance of the resistor. We have to find out the resistance of the resistor. So this is the question. So what is the given data here? So the potential difference is 12 volt and the current is, how much current is flowing in the circuit? It's 2.5 milliampere. 2.5 milliampere. We have to calculate the resistance of the resistor. Okay. Now we know that by Ohm's law, V is equal to I into R, right? So I is equal to V divided by R. Okay. Now you can write R is equal to V by I in order to calculate the resistance of the resistor. Now this is equal to V is how much? It's 12 volt. It is 12 volt. And we have the current. We have the current which is 2.5 milliampere. And here we need to convert the 2.5 milliampere into ampere because the SI unit for the current is ampere. How to convert this one? It's 2.5 as it is milliampere, means it is 10 raised to minus 3 ampere. Milli means 10 raised to minus 3. Okay, this is equal to, it can be written as 25 into 10 raised to minus 3 into 10 raised to minus 1. Why? Because just I have shifted this one point from here to one digit in the forward direction. So here whenever you are shifting the point in the forward direction, how many digit you have shifted, that much number you have to multiply here, that is 10 raised to minus 1. Now this can be written as 25 into, when the bases are same, indices must be added. So 10 raised to minus 4. Minus 3 plus minus 1 is equal to minus 4 ampere. Okay. Now put the value. It is 25 into 10 raised to minus 4. Right? Now simplify this one. Now we have 12 divided by 25. So here 12 divided by 25, right? Take one point. It is 120. 25 4s are, it is 100. Subtract this one. You will get 20. Take one more 0. 25 how much? 200. It is 8 200. 0 0 0. So how much we got? 0.48. So this is equal to, R is equal to how much it is? It is 0.48 into, here in the denominator we have 10 raised to minus 4. Take into the numerator. It is 10 raised to plus 4 according to the law of exponents. Right? Now this can be written as R is equal to 4800 ohm. Why? Because here we have 10 raised to 4. So here I have the point 0.48. I am going to shift this 1 point 4 digits forward. So 1, 2, 3, 4. It means I have to multiply with the number 10 raised to minus 4. So let I write this one, 0.48 into 10 raised to 4 as it is, into how many digit I have shifted? 4 digit I have shifted the point. So I need to multiply with the number 10 raised to minus 4. So 10 raised to plus 4, this minus 4, both are get cancelled together. I will get the answer, that is R is equal to 4800 ohm. So this is the answer. So the resistance of the resistor in the circuit is, it is 4800 ohm. So hence we have solved the problem. The next question is, a battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? So this is the question. So here we have a battery of 9 volt. We have a battery of 9 volt which is connected with the resistors in series. How many resistors we have? We have total 5 resistors. So first one resistor we have 0.2 ohm. Second one resistor we have 0.3 ohm, right? Third one we have, it's 0.4 ohm. Fourth one we have, it's 0.5 ohm. And lastly we have one more resistor which is 12 ohm. Okay. So these 5 resistors are connected in series across the battery 12 volt. Right? Now we have to calculate how much current would flow through the 12 ohm resistor. How much current would flow through 12 ohm resistor. Right. Now what is the given data here? Voltage, that is the potential difference, is 9 volt. Correct. And we have the resistors which are connected in series. It means we need to calculate the equivalent resistance in order to calculate the current in the circuit. So here we have to calculate for current, and also we have to calculate for the equivalent resistance, that is RS. Resistors are connected in series. Now we know that equivalent resistance, that is the resistors are connected in series. What is the formula? R1 plus R2 plus R3 plus R4 and R5. Total 5 resistors we have. This is equal to R1, it is 0.2, R2 it is 0.3, right? R3 it is 0.4, R4 it is 0.5 and R5 it is 12. add all these resistors. So 0.5, 9, 12, and it is 13.4 ohm. So the equivalent resistance in the circuit is 13.4. Okay, here we have to calculate the current across 12 ohm resistor. Okay, now here we know that the condition, whenever the resistors are connected in series, the current flowing in the circuit is same. The current flowing in the circuit is same. So here you find out the total current in the circuit. That would be the current flowing in the 12 ohm resistor. So by Ohm's law, we have V is equal to I into R. Therefore I is equal to V by R, right? I is equal to V by R, right? Now this is equal to V is how much? V is, it's 9. Okay, resistance, that is the equivalent resistance in the total resistance in the circuit. So we have calculated it is 13.4, right? Now this can be simplified as, this is equal to, can I take this 90 divided by 134. Just I have removed this one point from the denominator that I have taken into the numerator. So it is 90 divided by 134. Now divide this one. So we have 90. We have to divide with the number 134. So take one point. So it is you can take 1 0. It is 900. Now 134. How much the 900? So 134. 134. It is 6 it's 804. 134. 6 804. Now subtract this one. It is 96. Right. Now take one more 0. It is 960. Right. Now 134, how much the 960? 134 7s it's 938. Right. So subtract it one. Now we got 2 digit, no need to be further simplification. So this is equal to, I can write here 0.67 ampere. 0.67 ampere. So the current flowing in the circuit is 0.67 ampere. And here the question that how much current would flow through the 12 ohm resistor. So as the condition we know, as the resistors are connected in series, the same current will flow through each resistance. Therefore, in series combination of resistors, current flowing through each resistor is same. This implies that current flowing through how much ohm? That is 12 ohm resistor is 0.67 ampere. So hence we have solved the problem. The next question, how many 176 ohm resistors in parallel are required to carry 5 ampere on a 1220 volt line, right? So here we have to calculate the number of 176 resistors. They should be connected in parallel in order to carry 5 ampere of current on 220 volt line, right? So let's suppose that n number of resistors are connected in parallel, because we don't know that how many resistors we needed in order to carry 5 ampere of current. So what I have done, I have considered let's n number of resistors are connected in parallel in order to get 5 ampere of current. Okay, now we know that the equivalent resistance that is Rp is equal to, for n numbers, so it is how much? It is 1 divided by 176 plus 1 divided by 176 up to n. We don't know that one, how many we want, so plus 176, right? Now this can be written as Rp is equal to 176 divided by n, right? Just I have taken the reciprocal, and this side also, that is 176 divided by n. So this is the resistance. Okay, now we know that according to the Ohm's law, by Ohm's law, resistance is equal to V divided by I, right? Now what is the resistance? That is the equivalent resistance is, it is 176 divided by n. This is equal to, what is the voltage? How much they have given voltage? It is 220. What is the current? Current, it is 5 ampere of current, right? Now this can be written as 176 into 5 is equal to n into 220, right? Just I have done cross multiplication. I have taken this one this side, and I have taken this side. Therefore n is equal to 176 into 5 divided by 220. Just I have taken this one term to the LHS side, right? This is equal to, now multiply 5 into 6, it is 30, carry 3, 5 7s are 35 plus 3, it is 38, carry 3, 5 into 1 5 plus 3, it is 8 divided by 220 as it is. Okay, now 0 0, both are get cancels together. So here we have 22 ones and 22 fours. So n equal to 4. N equal to 4, which means 176 ohm resistors are required. How many numbers? 4 in numbers. Therefore total 4 numbers of 176 ohm resistors are required to carry 5 ampere of current. So hence we have solved the problem. the next question. Show how would you connect three resistors, each of resistance 6 ohm, so that the combination has a resistance, first one 9 ohm, second one 4 ohm. Here we need to be sure that the three resistors, each of resistance is 6 ohm, so that we need to so that the combination of resistance is 9 ohm and 4 ohm. So how we would connect these three resistors? So here we have R1, R2 and R3 is equal to 6 ohm, right? Now these three resistors, how we will connect in order to get the combination, that the equivalent resistance, that 9 ohm and 4 ohm. So let's find out for the first one case 9 ohm, how to connect that one in order to get 9 ohm equivalent resistance. So here what I will do, I will connect R1 which is having 6 ohm resistance with the parallel combination of R2 and R3. R2 is 6 ohm, R3 is also 6 ohm. Okay. So just I have connected these three resistors, that is R1, it is in series, okay, it is in series with the parallel combination of, that is R2 and the R3. So let's see that one, the total equivalent resistance, it will come 9 ohm or not, just we have to check it first. Okay, now here R2 and R3 are in parallel, right? R2 and R3 are in parallel. Therefore, the equivalent RP, that is the equivalent RP, 1 by RP is equal to, it's R2 into R3 divided by R2 plus R3. This is the formula when the two resistors are connected in parallel. This is equal to R2 is 6, R3 is 6 ohm, 6 plus 6. This is equal to 6 into 6 is 36, 6 plus 6 is 12, 12 ones are 12, 3 is are. Therefore, 1 by RP is equal to how much? It is 1 divided by 3. Therefore, RP is equal to 3 ohm. RP is equal to 3 ohm. Now we got the equivalent resistance for these two resistors. Now after that, redraw the circuit. Redraw the circuit. Redraw the circuit. Redrawing the circuit. So here R1, it is how much? It is 6 ohm, and the equivalent resistance for these two resistors we got 3 ohm. It is the equivalent resistance which is 3 ohm. Okay. Now these two resistors are in parallel. Therefore, these two resistors are in series. Therefore, Rs is equal to R1 plus R2. This is equal to R1 is, that is 6, and R2 is, that is 3 ohm. This is equal to 9 ohm. This is equal to 9 ohm. Look at here. So here, when the three resistors R1 in series is connected with the parallel R2 and the R3, you will get the equivalent resistance is 9 ohm. So hence this one, first one we have solved. Now come to the second part. Now second part, we have to be connect these three resistors in such a way that we will get the equivalent resistance, that is 4 ohm. So second, for the second one, how we will connect this one? We will connect the R1, we will connect the R1, we will connect the R1 and R2, R1 and R2 with the parallel combination of R3. With the parallel combination of R3. Let's see how to check it this one. All the resistances are 6 ohm. It's 6 ohm. And this one also 6 ohm. Right? Now, R1 and R2 are in series. Here, R1 and R2 are in series. Okay? Therefore, R equivalent is equal to R1 plus R2. This is equal to 6 plus 6 is equal to 12 ohm. Fine. Now, redraw the circuit. Redraw the circuit. So here R1 and R2 equivalent, we got how much? It is 12 ohm, and we have one more resistor which is how much? It is 6 ohm resistance. Okay, now these two resistors are in parallel. Here 12 ohm and 6 ohm are in parallel. Therefore, RP is equal to, okay, therefore RP is equal to R1 into R2 divided by R1 plus R2. This is equal to R1 is 12, R2 is 6 divided by 12 plus 6. This is equal to 12 6 it's 72 divided by it is 18. 18 1s are 18. 18 4s are 72. Therefore, R equivalent is equal to 4 ohm. So here you can see here 4 ohm. You can see here when I have connected 3 resistors R1 and R2 in series with parallel R3, I got 4 ohm resistor. 4 ohm resistance. Similarly, when I connected R1 in series with the parallel combination of R2 and the R3, I got the equivalent resistance which is 9 ohm. So in this one manner, we have to be calculate the equivalent resistors. So here one small mistake I have done. Let I correct this one. So here it should be, when you are taking directly, it should be written RP, not 1 by RP. Okay, right? So hence we have solved the problem. The next problem is, several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across 2 wires of 220 volt line if the maximum allowable current is 5 ampere. So here we have the question. Now we need to calculate the number of bulbs that which are connected in parallel, that in order to allowable current is 5 ampere through the each lamp. So first of all, here we need to calculate the resistance of each bulb, then only we can calculate the how much number of the lamps needed in order to connect in parallel. Okay, so resistance of each bulb, R is equal to, we know the relation, V square divided by P, right? And here what is the given data here? They have given power which is 10 watt, and we have voltage that is 220 volt. Voltage is 220 volt, right? Therefore resistance is equal to V, it is 220 into 220 divided by power, it is 10 watt. 0 and 0 both are get cancelled together. Therefore R is equal to, it is 4840 ohm. So the resistance of each bulb is 4840 ohm, right? Now these bulbs which are having the resistance 4840 ohm should be connected in parallel. So how many number of bulbs should be connected in parallel? That is it should be allow the current 5 ampere. So let's suppose that n number of bulbs are connected in parallel. We don't know that one how many number of bulbs we needed. So let I take n number. Therefore the equivalent resistance is equal to, that is 1 divided by how much? That is each resistance is 4840 plus 1 divided by 4840 up to, that is n number 4840. We don't know that one how many number of bulbs we need. So let I have taken here n. So here this can be written as 1 by Rp is equal to n divided by 4840, right? This implies that Rp is equal to 4840 divided by n. We got the resistance, the equivalent resistance for n number of bulbs. Now here by Ohm's law, we have R is equal to V divided by I, right? And here R is how much? It is 4840 divided by n. V is how much? It is 220. What is the current? Here? The allowable current is, it is 5 ampere. So it is 5, right? Now 4840 into 5 is equal to 220 into n, right? Just what I have done, I have just taken cross multiplied this one, right? Therefore n is equal to 4840 into 5 divided by 220, right? Now 0 0 both are get cancels together. 22 ones are 22, 22 ones are 22 twos are 44, and 22 twos are 44. So 22 into 5, it is 110. So here total number of bulbs needed 110 bulbs which are having the resistance 4840 ohm. The bulbs are total 110 bulbs needed. So here hence we have solved the problem.